Welcome to the European Space Research and Technology Centre ESTEC. Here in Noordwijk on the Dutch North Sea coast is ESA's largest establishment focused on developing technology, planning future space missions and testing satellites. ESTEC is home to Europe's largest satellite test centre. Missions like the 20-ton ATV space truck, Envisat, the world's largest civilian Earth observation mission, and pretty much 24 Galileo satellites have all been tested here. So while thermal vacuum testing of satellites takes place, and that means subjecting them to the equivalent vacuum and temperature extremes of outer space, then around 50,000 litres of liquid nitrogen, super chilled, comes through these gates every day just to top up ESTEC's own supply and keep the giant vacuum chambers as cold as outer space. Each morning, the flags of 22 ESA member states are run up here, along with the flag of partner nation Canada, and then run down again for sunset. These are the 22 member states of ESA, an intergovernmental organisation set up to accomplish tasks in space which are too big for any one country to accomplish. ESTEC is the technical heart of ESA, with more than 2,700 scientists, engineers and support personnel working here, although fewer on site at the moment due to COVID restrictions. That includes people from all ESA member states, plus Canada and other cooperating states, and associate members on the way to full membership, as well as trainees, students and visiting researchers. ESTEC itself was set up more than half a century ago, before ESA itself, and actually ESTEC's very first space mission was launched back in 1968. And this part of the ESTEC complex was built by renowned Dutch architect Aldo van Eyck, who's well known for designing hundreds of children's playgrounds. And here we have a clock allowing you to set your watch to ESTEC's very own time, which is accurate to a few billionths of a second. It's actually set by a set of atomic clocks down in the basement, and they need such precise timing to help do an independent check of the Galileo system's time performance, and also for some extremely ultra-precise experiments that the ESTEC laboratories run. This main corridor, nearly 200 meters long, was originally designed for the manufacturing of sounding rockets. It works like the backbone of ESTEC, joining project offices with the laboratories and the test center at the very end. And here at the end of the corridor, we have the drop test model of the intermediate experimental vehicle, designed to be a reusable spaceplane. This model was used for testing parachutes, splash landing into the Mediterranean ahead of IXV's actual flight in 2015. And now a follow-on mission called Space Rider is in the planning stages. This will be a fully reusable spaceplane. It'll launch on the ESA's Vega launcher, spend up to 2 months in orbit as an uncrewed space station, and then return back down to Earth, making a precision landing. And Space Rider's first flight is due in 2022. There's history all over the place at ESTEC. This isn't a wall hanging, but actually part of the Hubble Space Telescope's solar panels. And this spent 8 years in space before being brought back to Earth by Space Shuttle. So ESA contributed the first 2 pairs of solar panels to the Hubble Space Telescope. And when they were brought back down to Earth again, it gave researchers valuable insight into what actually happens to materials in space. So you look closely, you can see micrometeorite damage. Opened by the then Prince Willem-Alexander of Holland, is home to many of ESA's world-class technical laboratories, which look into every different aspect of spaceflight. And there are plenty of space relics here as well. This here is a working model of the docking ring used on the Russian part of the International Space Station, also on ESA's ATV space truck. And so a version of this is still used in space now. And further down here we have something very special.
This is indeed very special for us. It was the first time probably in the world that we have 3D printed moon regolith, actually a simulant of the moon regolith, so the dust that is on the moon, to build the structure of a potential moon base on the surface. And here the beauty of this is not just from engineering perspective, from a technical perspective, the realization of it is the thing that we change completely the engineering approach to a mission like that. So instead of launching the material to build the moon base, we are using the material that is already on the moon base to 3D print it and using the sun as a source of power to bake layer by layer the moon base itself. So you are not launching it, you find the resources on the planet. We do two main things in our day-to-day work. On one side, we qualify all materials and all processes for all the missions that ESA is flying today. And on the other side, we are identifying and keeping screening the, let's say, technological landscape to find the materials for the future missions. So if you want, it's a very privileged position. That is, on one side, we see all the materials, we qualify all the materials and all the processes for all the missions. On the other side, we try to find the next breakthroughs to make possible the next future and very challenging missions that ESA is doing.
In here is ESA's propulsion lab, which is looking at ways of moving spacecraft in space. What look like giant bottles are actually vacuum chambers, and these are used to recreate space conditions, in particular for the testing of a new generation of electric thrusters. These use electricity to excite thruster propellant, and which ends up being much more fuel efficient than traditional chemical thrusters and can get missions to places where we couldn't go before. Not all ESA plans come to fruition. This is a model of the Hermes space shuttle from the 1980s, which underwent preliminary design at ESA but was eventually cancelled. Elements of its technology, however, fed into missions such as the IXV spaceplane, the ATV space truck, and the European robotic arm, which is soon due to join the Russian segment of the International Space Station. This is the Erasmus Center for Human Spaceflight. The building was originally constructed to help test docking between the Hermes shuttle and the Columbus module now aboard the International Space Station. And Erasmus serves researchers interested in microgravity and life in orbit. They work on experiments for the International Space Station from here, and they also organize regular parabolic flights, which, as they fly in the air, give researchers brief access to microgravity. Here in Erasmus, there's this 13-meter high drop tower demonstrator, which, when you drop something down, it gives 1.6 seconds of microgravity. Okay, let's give it a try. If researchers need more microgravity time, then they can use ESA's full-size ZARM drop tower in Germany, which is 146 meters high and incorporates a catapult to give more than 8 seconds of weightlessness at a time. If they want more than that, they can go on parabolic flights. If they want even more than that, then they go to space on either dedicated missions or the International Space Station. And also here in Erasmus, we have a little bit of Mars on planet Earth. This is ESA's 8x8 meter Mars yard, part of the Planetary Robotics Lab. And here is where the agency puts its rovers through its paces. What we're looking at here is locomotion. We want to see how the rovers will move on the surface of Mars, the Moon, and other planets and asteroids. We're here now in the longest lab in the ESTEC. This is the Orbital Robotics and Guidance, Navigation and Control Lab. And I'm here with Olivier Dubois-Matra, a GNC engineer and one of the lab managers. So Olivier, what did this lab do?
The lab here hosts one of the facilities that we are using here in my section of Guidance, Navigation and Control. The name of the facility is GRAS, GNC for Guidance, Navigation and Control, Rendezvous, Approach and Landing Simulation. And we use these devices to reproduce the kinematic that you may encounter during a space mission, rendezvous or landing. And here what you can see is that we are moving around the mock-up of a satellite. And the idea is to reproduce the optical environment of an actual rendezvous in space. And this way we want to test a future concept for a rendezvous mission with satellite or with derelict satellites that need to be deorbited, or also land on the Moon or asteroids.
The lab also includes this, the flattest floor in Europe. It's an epoxy floor, 4.8 by 9 meters across, smoothed out to 0.8 millimeters and kept scrupulously clean of dust. And the idea is that you can have robots hover across it, kind of like an air hockey table, to reproduce in 2 dimensions the kind of movement you get in 3 dimensions in weightlessness, in microgravity. ESTEC is run as cleanly as possible using renewable electricity sources and green gas, and also water is recycled to keep the site going. As you can see, it's a haven for wildlife. These ponds help with that. Although the ponds weren't originally dug for that purpose, they're actually to make sure that the site has plenty of water if the ESTEC Fire Brigade ever needs to fight a fire, because there was a fire here back in 1966 when they were building the site, and it ended up pretty much clearing the entire complex. And this is as far as we can get into the ESTEC test center on this particular tour. Behind this gate is an airlock door leading to a 3,000 square meter environmentally controlled clean room complex filled with test facilities to simulate every aspect of the space environment. For instance, they have Europe's largest sound system to simulate launch noise as a rocket takes off, an earthquake strength shaker system to simulate launch vibration, and they have Europe's largest vacuum chamber so we can place complete spacecraft inside space-like conditions for weeks on end. So ESTEC isn't normally open to visitors except during the ESTEC Open Day once a year, but it does have a public visitor centre just next door, Space Expo. And I'm here with the head of Space Expo, Barbara Hopple. So Barbara, what can people see when they come here?
Well, come here, they can see a lot of nice and interesting objects, and we have, well, for instance, capsule, the Soyuz capsule, André Kuipers traveled with, and also a life-size model of the ISS. But we also have a special tour, a COVID-19 proof tour, and well, it guides you through the museum. We're open 6 days a week, from Tuesday to Sunday, so you're welcome.
So we hope to see you at Space Expo anytime. In the meanwhile, this is Sean Blair, Freezer Communications, signing off.